Let's have a look at energy changes in chemical reactions, shall we? Roll that graphic. Hi, I'm Paul. This is Science That Sticks. In this session, I'm going to carefully go through exothermic reactions and endothermic reactions. These are changes in thermal energy, heat energy, when a reaction takes place. Most of the time there is some sort of reaction taking place that it's accompanied with an energy change, and that energy change almost always is heat. That's not strictly the case because sometimes it could be light as well. But let's concentrate on heat energy at the moment. There are two main types. If something gives out heat, such as striking a match, that's a combustion reaction. The fuel is the match. We get it started by the friction and the little bit of chemical, the oxidizing agent on the tip of the match. That produces an exothermic reaction. Heat is given out. Now, there are other reactions where heat is taken in. For example, those cold compressors that you get in schools and colleges. You put it on the affected area, it gets colder and colder and colder. An endothermic reaction. One of the things you've got to know for assessment purposes is how to draw the reaction profile. So I'm going to start with just the simple idea that reactants form products in a chemical equation. Let's look at this. So, simple idea. Reactants make products. I'm going to shorten reactants to react and products to prod in the two different kinds of energy profile diagrams I'm going to draw. So I'm going to start with this one. So I've got progress of the reaction here. And I've got energy here. Now in this case, I'm looking at heat energy. It doesn't really matter what kind of energy it is, but let's consider heat energy. Well, we start off with our reactants, and they happen to have a certain amount of internal energy. Their bonds have got energy in them. I'm going to make this a little bit longer. There we go. Now, if it is exothermic, the products, the chemicals themselves of the products, have less energy than the reactants do. So they're lower down. To get from here to there, you have to overcome an energy barrier. We call this the activation energy. Now, sometimes it's shown by a little wave going up and down. Now, this difference between where the reactants are and the top of the energy barrier, this is called the activation energy. The energy of the reaction is this difference from here down to where the products are. Now, because this is a negative gradient from reactants to products, that heat energy has to go somewhere, so it goes out into the surroundings. The reaction gets hotter. Easy. Now, if it's endothermic, the reverse is true. So let's have a look over here. Once again, we've got our progress of the reaction, which I'm going to shorten to just progress because I want to keep this video fairly short. And I'm going to have energy over here as well. I'm going to have my reactants. Again, I'm shortening this to reacts. Now the products have got a higher energy than the reactants, so they go higher up. There's still an activation energy to be overcome, but unfortunately in this case the activation energy is massive. And that would be the difference between here and there. So that's the activation energy. Now, most of the time we call it EA. Not because it's in the game, but because it's short for activation energy. You'd think it would be AE, but no, there we go. But the change in energy is here. So that's the change in energy. Now, in this case, the change in energy would be positive. This means it's taking energy in from the atmosphere, and it gets, or from the surroundings, and it gets colder. In the case of the exothermic, the energy is released to the surroundings, and as a result, it gets hotter. That's it. Learn those two. Make sure that you're able to fill in a diagram of any description, endothermic or exothermic, given any reaction that you're presented with in an assessment. Fully label it. Make sure you know where things should be. Where are the reactants supposed to be? Where are the products supposed to be? And crucially, identify in the exam question if it says exothermic or endothermic reaction, or state that the energy change has gone up or down. For GCSE students, you're looking at a temperature change. If it gets hotter, it's exothermic. If the temperature goes down, it gets colder, it's endothermic. That's it. Till next time, ladies and gentlemen, stay cool. Goodbye.